In some problems, you're going to be asked to represent the relation. Now, we can represent relations in a lot of different ways. We can represent them as ordered pairs. We can represent them as a graph. We can represent them in a table or a mapping diagram. So we're going to focus right now just on a graph and a mapping diagram. This relation has already been given to us as ordered pairs. When it says represent the relation as indicated, this graph is the indication here, you're basically going to plot those points on the graph. So 2, 0 would be right here, 1, negative 1, 2, 2, 0, 0, and negative 1, 1. There you go. That's representing the relation. Again, we're just talking about how we can represent things, not that this is totally new things. Remember, we've been dealing with relations and functions, well, for the last few years in math. We just didn't refer to them necessarily as a relation, or we didn't think of them that way. So if you're asked to represent the relation as a graph, you just plot the points. They can be represented as ordered pairs. They can be represented as points on a graph. Mapping diagram might be a little bit different, something new, but it's not difficult. Basically, you're going to list your inputs and outputs, the domain and range, in order, least to greatest, and you're going to draw arrows. Here's what I mean. We start in a mapping diagram by identifying our two columns. We have our inputs and our outputs. And now our inputs, remember, are all our x values, our domain. Write them in order going down, no repeats. So looking at this, I would have negative 1, 0, 1, and 2. Our outputs then, our y values, our range, we're going to have negative 1, 0, 1, and 2. So what we just did is we just set up all of our inputs and our outputs, and now we're going to draw arrows to represent the relation. If I look at this one right here, 2 goes to 0. My input 2 goes to my output of 0. My input of 1 goes to my output of negative 1. My input of 2 goes to an output of 2. 0 goes to 0. Negative 1 goes to 1. And that's it. That's a mapping diagram. So again, just another way to represent a relation. And the reason we have these different ways of representing relations is because they help us determine if a relation is a function. So you're going to have to flip back in your notes and write down what a function is. A function is a relation if for each input there is exactly one output. If for each input there is exactly one output. So some of the relations we've been working with just in this lesson are functions. Some of them aren't. And it's okay if it's not a function. There's nothing wrong with the relation. It's just not a function. So let's look at some of the relations we've been working with. This first one here says tell whether the relation is a function and explain your reasoning. Well, that was the hours driven, or hours driven, how many miles traveled question. Now, if we go way back to that problem here, you can see that each input goes to exactly one output. When I input a 1, I get out 60. I don't get anything else out. So we would say that yes, this is a function. Tell whether the relation is a function. Then explain. You can literally just say every input has exactly one output. Something to that effect. Let's look at the second one here. This is kind of the relation we were just working with. Is this a function? Well, remember, a function is a relation if for each input there is exactly one output. Let's look at our mapping diagram here. If I input this negative 1, it goes to 1. Nowhere else. If I input 0, it goes to 0. Nowhere else. If I input a 1, I get out a negative 1. So far, so good. But look right here. If I input this 2, I either get out 0 or I get out 2. There's nothing wrong with it. It represents 2 points on a graph. It can be ordered pairs. There's nothing wrong with it except it's not a function. Because a function is a relation is a function, if each input there's exactly one output. And there's not here. If I input a 2, I could get 2 different things out. So we'd say here, no, and then you just explain. You could say, the input 2 has 2 outputs, you could say not every input has exactly 1 output. You could just show me that, 2 goes to 0 and 2 goes to 2. Okay. But somehow you want to just tell why it's not a function. Nothing wrong with it again. It's still a relation. It's just not a function. Now the last thing we want to talk about is the vertical line test. And the vertical line test is a quick way of telling on a graph whether a relation is a function or not. If you can find a vertical line passing through more than one point of the graph, then the relation is not a function. Otherwise, the relation is a function. So let's look at a couple examples. If I were to take a vertical line across this graph, you look at where it hits the points. Hits one point there, hits a point there, but look right here. Do you see how it hits 2 points at the same time? Is this a function? And the answer is no. The input 2 goes to 1 and the input 2 goes to -1. Just not a function. If you look at this example, if you were to run a vertical line across this example, here it hits the point 2, 2, it hits 1, 0, 0, -1, -1, 1. It never hits 2 points at the same time. So is this a function? Yes. Again, the vertical line test is just a quick and easy way to tell whether a graph is a function or not. And what we'll see is we're going to use that when we're dealing with like linear functions, straight lines, quadratic functions where we have like a U shape. You can run a vertical line across it just to tell whether it's a function or not. Again, they're all relations. It's a pairing of an x and a y value, and then a specific type of relation is a function.